Hi all, so this is another homework video, so I'll be going over 4 proofs that we did in 7.2.3, just a random selection here. So the first one we want to do is number 6. So 6 says if L or T, then B and G. And then we're also given L and K if and only if R. And what we're trying to find is L and R. So L and B. L and B. So how are we going to go about doing this? Well, let's look at our conclusion. So our conclusion, the main operator is a dot. And we have L and B. One of the main ways that the chapter went over that we can derive a dot is by getting each piece of it independently. So if we get L on a line and if we get B on a line, then we can do conjunction and conjoin them together and get L dot B. So we'll be looking to isolate those statement variables and then conjoin them together. So on line 2, we see L. And that will be pretty easy to get because we have the main operator as a dot with the L being to the left. Simplification will let us get that. In fact, let's go ahead and get that right away. So we can get L, and how did we do that? We just did 2 simplify. And now that we have L, we need to get B on a line by itself. So B's up here in this big line. So luckily, B appears in the consequent of a conditional statement. And if we can get this consequent on a line by itself, then again we could simplify the B out and then conjoin it with the L to get our answer. So how are we going to get the consequent on a line by itself? Well, usually the way we do that is by modus ponens. Modus ponens down here on the right tells us that if we have if P then Q, and if we have P, so everything to the left of the horseshoe, then we can get Q, everything to the right of the horseshoe. So what we need an L or T. And we look around, we don't see an L or T. In fact, nowhere else in the proof do we see a T. So we're going to need to add that in. Whenever we see a variable that we need, that we don't have, we need to just add it in after a wedge. And look, it's after an L, L wedge T. And here on line 3, we have L. So we can just add the OR T. And that was 3 add. And why did we add the OR T? Because it's exactly what we needed to get L or T. That's the antecedent, and then we can use MP to get the consequent. So remember, you can add anything you want if you put a wedge and then whatever you want. All right, so now we can do 1 for MP, and that will get us B dot G. And now it's just a couple steps to the finish. We're going to simplify 5. And now on line 3 and 6, we have L and we have B. So then we can combine them together. Sorry, conjoin them together. That was 3, 6. To get L dot B. And this is what we were going after. Here's what we got. We did it in 5 lines, and we justified every step along the way. So we're finished with that one. All right, so let's look at 12. In 12, we have if P then R, then if M then P, P or M, if P or M, then if P then R, and P or M. And what we're trying to get is R or P. So the first thing we should do is take a look. Well, first let's recognize that what we're trying to derive is a wedge. And when we're trying to derive a wedge, we're likely looking at one of two strategies. One being addition, so finding R and then adding or P. That would be one way to go about this, one way to think that we might go about it. The other way would be construct a dilemma down here in the bottom right, also ends with a wedge. So for that, we would need a conjunction of conditional statements, and then we would need the disjunction of the antecedents to find the disjunction of the consequence. So the way we can figure out if this is going to be a constructed dilemma is see if the disjunction that we have here is a disjunction of consequence. So let's see where we find R. R is a consequent here. It's also a consequent here. So P horseshoe R. And then where do we find P? Well, P is an antecedent here, but it's also a consequent here. So I bet we're going to be using constructive dilemma to derive this conclusion. So how are we going to set that up? Well, here we have the disjunction of antecedents P or M. But note, this would be a perfect one-line proof if this horseshoe was a dot, because remember, we need in constructive dilemma down here in the bottom right, we need a conjunction of conditional statements. So we're going to need to set that up somehow. So let's see if we can isolate some of these conditional statements, and then we'll try to conjoin them together. So how can we get P horseshoe R by itself? Well, it appears there, but that's going to be tough to get by itself. But it also appears here as the consequent of a conditional statement. So if we have the antecedent somewhere, we can get the consequent via modus ponens, and we do have this antecedent down here on line 3. So let's go ahead and get P horseshoe R on a line by itself, and we did that by 2, 3, M, P. All right, so as usual in these proofs, we look at what this new line can do for us, and it can do a lot for us, because we look at line 1, we see the antecedent is P horseshoe R, and that's what we just got, P horseshoe R, so now we can get the consequent again via modus ponens. So here we'll get M horseshoe P, and that was 1, 4, MP. And now we have P horseshoe R and M horseshoe P. And here we have the disjunction P or M, and note those are the antecedents down here. And what we're trying to find is R or P, and note that those are the consequents here. And constructive dilemma tells us if we have the conjunction of conditional statements and the disjunction of the antecedents, we can get the disjunction of consequence. So we need to just conjoin 4 and 5 to get P horseshoe R and M horseshoe P. And that was just 4, 5 conjunction. And now that we have that conjunction on line 6 and lines 3, note 3 is the disjunction of the antecedents of 6. So we can do constructive dilemma and end up with the disjunction of the consequence. So that would be R wedge P. And that was 3, 6, constructive. So the constructive dilemmas, again, are a little tough if you don't see them coming, but suspect them if you see suspect either the constructive dilemma or addition if you see a disjunction as what you're trying to derive. All right, moving on. Let's do number 15. So 15 we have if either not S or B, then either S or K. And if either K or not D, then if H, then S. And then we're also given not S and W, and we're trying to get not H. So as usual, let's look for the conclusion. Here we're trying to get tilde H. The only place we see H is here, but it is the antecedent of this conditional statement. So if we can get that on a line by itself, I bet we could end up with tilde S somewhere. There's a tilde S. And then we could do modus tollens to get that. But let's just start by doing what we can to get this thing started. A good rule of thumb, if you have a dot, the very first move you should make is just get the left-hand side of that dot on a line by itself. It's an easy move, you can get points for it, and usually it's helpful getting you to where you want to go. So we're just going to simplify 3 here. And now that we simplify 3, and get tilde S, let's see where that leads us. So can we use a tilde S somewhere? Well, not directly, but look at line 1. In line 1, we have tilde S or B being the antecedent of that conditional statement. And we know that we can add anything we want after a wedge. So let's go ahead and add a wedge B after this tilde S to construct the antecedent for line 1. So tilde S, wedge B. We just went ahead and added that to line 4. All right, so now that we have the antecedent to line 1, we can get the consequent via modus ponens. Hopefully you're familiar with that move by now. All right, so now let's take stock again. Recall our ultimate goal here was to break this line down, to isolate H horseshoe S so we could get tilde H out of there. And here we have S or K. Now, how is that useful? Well, what we're trying to get if we're trying to isolate this is we're trying to get K wedge tilde D. So how can we get K wedge tilde D? Well, here we have S wedge K. So one thing we could do is if we could get this K by itself, we could just add that or tilde D and then construct that antecedent and do modus ponens to get the consequent like we just did on lines 5 and 6. So can we do that? Yes, we can. Can we get K by itself? Here we have S wedge K, and here we have tilde S. So we can go back to 7.1 and do a disjunctive syllogism to get K on a line by itself, and that was 4, 6. Disjunctive syllogism. And now that we have K on a line by itself, what we're trying to get is K wedge tilde D on the way to getting H horseshoe S. So how can we get K wedge tilde D from K? We can just go ahead and add it. And now that we have K wedge tilde D, we have the antecedent to line 2, so modus ponens will let us get the consequent. Alright, so 2 and 8 MP got us H horseshoe S, and recall what we're trying to get is tilde H. Now we have it as the antecedent here. Modus tollens tells us we could throw a tilde in front of that H as long as we somewhere had the negation of the consequent S, and we do on line 4, we have tilde S, so we can get tilde H, and we can get that from 4, 9, And we got there. Looking for tilde h, we got tilde h, justified all our steps, we're all good. All right, so one more. I'm going to go ahead and do number 20 as well. All right, so here we're looking for B or G. Disjunction again. Recall that we should suspect either addition or constructive dilemma. The way we determine which one we'll find is, can we find both of these parts in here, a B or a G? Here's a B, it's the consequent of a conditional statement. Here's a G, it's the consequent, or sorry, this is the consequent of a conditional statement, and G is also the consequent of a conditional statement. So what rule will we suspect? Since they're both in here and they're both consequence of conditional statements, we're going to suspect constructive dilemma, which gives us consequence of conditional statements. So we're going to be setting up a disjunctive syllogism here. What else will we need? Well, here we have D or F. So we need another disjunction to set this up. So probably what we're going to want is D horseshoe B and F horseshoe G, and then we could use this disjunction to get this disjunction. So we need to set up D horseshoe B and F horseshoe G. So can we get D horseshoe B? Yes, we can. Look at 2 and 3. So there we have D horseshoe tilde C and tilde C horseshoe B. Hypothetical syllogism is going to let us right off the bat get one of the things we want here. So it's going to let us get D horseshoe B from 2, 3 HS. So now we have D horseshoe B, and so now what we want to get is F horseshoe G. F horseshoe G is right here. How are we going to get F horseshoe G? We're going to need M or N. So where do we see anything like that? Well, here's an M. Oh, nice. It's the first conjunct in a conjunction. So we can get that on a line by itself, and then we could just add the or N to get that by itself. And then we can start piecing together our constructive dilemma. All right. So on line 7, let's go and simplify line 4. And now that we have M, we can construct that antecedent. This is, as you hopefully have noted, a very popular move in these proofs. So this is just adding on to 7. And now that we have that antecedent, we can get the consequent. F horseshoe G via modus ponens, so 1, 8 MP. And now that we have, recall what we were looking for was D horseshoe B, and when we got that, and then we also wanted F horseshoe G, and now we got that. So if we conjoin these conditional statements, then we'll have our constructed dilemma fully arranged here. So first what we need is D horseshoe B. And then we also need and F horseshoe G. So we just conjoined 6 and 9. Yes. And then we have set up our constructed dilemma. So look at lines 10 and 5. 5 is the disjunction of both antecedents there. So we can get the disjunction of the consequence. dilemma. And there we got to B or G. That's what we were trying to do, and it actually wasn't all that long. We just needed to think our way through the constructed dilemma. So when you see a disjunction of consequence in the thing that we're trying to derive, look for something that might be the disjunction of antecedents, or how we might construct a disjunction of antecedents. Join. So then you can figure out what you need, because these will be the antecedents, these will be the consequence. Then you know what you need, then you find them in the proof, isolate them, and conjoin them together, and then you can run your constructed dilemma. All right, hopefully that was easy enough to understand. Hopefully you're staying up with this. If you're not staying up with this, I've got just a couple emails about proofs that have been difficult, or questions about general questions about proofs. Maybe I should go over one of those right now. I got a question: does the order matter, or can there be multiple ways to do proofs? And the answer is no, the order doesn't matter. Yes, there can be multiple ways of doing proofs. For example, in number 20 here, I needn't have started with 2-3 hypothetical syllogism. I could have just simplified for immediately on line 6 and done the hypothetical syllogism later. And that's totally legitimate. As long as every step in your proof is uses or is justified by one of these rules of inference, then you're all good. So if you have any other questions, go ahead and send me an email. Hopefully this has been helpful. I'll see you for 7.3.